So let's start with network automation day 1. Now see, the thing is that one is what is called as the traditional network. In traditional network we have switches, we have routers, right, and then they are connected, and all those things what we learned, like we configure router 1, router 2, router 3 for OSPF. Then if there are switches, so then we are doing spanning tree, rapid spanning tree, etc. But at times, don't you feel that it is like a repetition? It is like a repetition. We are doing same thing again and again. Maybe it's like, say, IP addresses are changing, but as such, technically speaking, we are repeating the same thing. We are actually typing the same commands for almost all devices. Now, how nice would it be if this entire thing is centralized, so that there is one piece which is controlling all those devices. So we give just command over here, and then it would follow for all of the devices. This is what is called as the controller based networking. Now in case of controller based networking, we need to understand certain concepts, and those concepts are that this controller is nothing but it's a piece of software, and it is this software which will be controlling rest of the networking. So to understand it, the foundation of it is that how are the three planes which will be operating at various levels. So these planes are like, one is data plane, second is control plane, and third is the management plane. And these are the three planes on which we'll be working. So let's start with that what is data plane. Now initially this will be a bit easy, but as we'll progress you'll find that lots of imagination would be required. So that's the reason that just remember these three planes very clearly, that what exactly will they be doing. For the data plane, all you need to understand that it's also called as the forwarding plane. This is forwarding plane. So whatever you have learned till this point of time, that this is one device, right? Data comes, then it is forwarded, and all the processes whatsoever are happening in this, for this particular situation, this is what is called as the data plane. In other words, remember the word data, how the data goes from one machine to another machine, one system, one device to another device, right? How it is forwarded. So this is the key thing, forwarding the data. Now this would be still more clear as soon as we talk about the second part. The second part, which is called as the control plane. Now what control plane is doing? Control plane is, say, all those tables, right? Whenever we have to, say, forward anything, right, we'll be utilizing those tables. So it's like we say that when the data comes, that data, that device would look into the routing table and then will take a decision that should I forward it on router 2 or router 3. Over here in control plane, we are handling all the tables. So decision to use which entry that goes into data plane and making those tables, that is what is called as the control plane. So in control plane, it will handle, say, your routing tables, it will handle your MAC table, it will handle your ARP tables, right? ARP tables. So one interesting thing is that here we are not talking about layer 2 or layer 3. We are just talking about that there is a device, whether router or switch, whatever the function which is doing, it is doing two things. One, it is making those tables. Whether if it is a router, so it is making a routing table. If it is a switch, it is making that MAC table. ARP is getting utilized for IP to MAC as when needed. But tables which are getting prepared, that is what is called as the control plane. And using those tables, the decision when it is taken to forward the data, it is called as the data plane. Right? This is the data plane. So we have a data plane and we have the control plane. Okay. Then there is a third plane, and that plane is management plane. That plane is management plane. Now in management plane, the name itself is telling that it is to manage devices. You will be managing those devices whether remotely or locally, but it is for management. So you might be using, say, telnet, you might be using, say, SSH, right? So that is what would be used by network engineers. Now to make it still simpler, let's say we are into, say, Cisco manufacturing unit, and we decide that we want to make a Cisco switch. So this is like making of a switch. In making of a switch, we decide that we'll be making a switch with 24 ports. And then this each port would be of, say, 1 Gbps port. So in that case, let's say calculate something. We say that a frame of 25 bytes would be traveling. Now this is just for the sake of ease of calculation, right? So this is 125 bytes. So 125 bytes, 125 into 8, right? That comes to 1000 bits. So we have got a frame of 1000 bits. Now when it is 1000 bits, so this is 1000 into, let's say this is into bits, we convert into KB, into MB, and into GB, right? So this is 1000 into 1000 into 1000. So this is like when we have got 1 frame per second, so it becomes, and then we divide it by that each frame is of, say, 1000 bits. This is what? This is 1 Gbps. And this is what? This is size of one frame. Size of a frame, right? So we cancel this. It means we are dealing with frames per second, right? This was the bandwidth and this was the frame size. So by dividing it, we figure out that these many frames per second per port, right? Per port. So this once again is to be multiplied by 24 because there are 24 frames. Now when these things are happening, so obviously say number of frames, in reality they are much higher than this. This is just an example to show that how many frames are getting handled by even a simple switch. So over here we have something called as ASICs. We know this part that it is the MAC address table. Once it is prepared, ASICs will be utilizing it. But when we are doing this thing, if we really want to improve our speed, so we know this part that this is the ASICs which is for table lookup. But then there is another memory. This is called as the TCAM, ternary content addressable memory. This memory is much faster. So what ASICs does is it will send this data to TCAM. Instead of reading from the table lookup, it is like you are deploying someone for your work, right? And this TCAM would feed the results directly, and thus the speed would be increased. This is very similar to that we do have CPU, but then we do have a GPU, graphic processing unit. If there is no GPU, so then it is the CPU which is taking care of it. But if there is GPU, so then obviously CPU is freed and it is GPU which is taking care of that graphic portion. So the CPU can work more effectively. So same thing over here, this TCAM is taking care of this search and it is giving fast results. Okay. So let's combine all these things and let's put every slot in this way. Say we have got CPU. It uses iOS, right? And this CPU will be working on RAM, and we always say that RAM is like a playground. RAM is like a playground on which entire iOS plays. And we have got ASICs, and this ASICs will be talking to TCAMs for fast results. So the entire table lookup portion that is handled over here. Now we know that table lookup, right? Table lookup and say this iOS part. So over here, this and this. This is the control plane where we'll be dealing with the management of the switch. So thus, let's take it into one more new word, and this is what is called as the switch abstraction. Switch abstraction. So it is switch abstraction, that is nothing but the concept of this table lookup. Okay. Now same thing was taken into a slightly higher level in case of say router. That if there can be a specialized hardware for switch, so there can be a special hardware for even a router also. So this is like a special hardware for router, and that is what is called as the quantum flow processor, right? That is what is called as the Cisco quantum flow processor. So these are like some very high speed processors which will be helping for the calculations of say routers. So now we start with the concept of, say, our data plane, control plane, and the management plane. We know one thing, that it is the control plane which is vital, because it is the control plane where we have to make all those tables, right? Making tables, and that is something which is tedious. Now, as such, if I say you go back to OSPF, in OSPF there was something like DR and BDR, right? DR and BDR. So what was the function of DR? DR was doing just one thing. It was collecting data from everyone, right? That is the tables. I mean, it was making the table and then it was sending this table to everyone. So it was collecting data from all of the other routers and was making table. In case if DR was failing, so then BDR would take over. But in any case, this is something like a centralized concept. Centralized concept. Say in case of static routing, everyone is counting, everyone is calculating. But when we are talking about, say, OSPF or other routing protocols, things are centralized. Over here, it is getting centralized even at much better level. So we have, say, they are called as the controllers. Now these controllers, they are nothing but they are software. They are software. It is like a centralized application. It is the centralized application which is running on specific hardwares, but it is handling all rest of the systems. So that's the reason this thing is also called as the software based architecture. It is also called as software based architecture. So it does what? It does processing for all devices centrally. And this is what is called as the SDN controller. So this is software defined networks controller. Now the degree of controls, that would vary. Means, will this controller control everything? Well, it depends. It depends, because it is in your hand. So this degree of control, that will vary. It varies. Now there would be some controllers who will be controlling everything, right? So they'll be controlling all functions. Two, there would be few controllers, those who will be controlling few functions. This thing would vary, but yes, they are capable of handling so many things, right? So we just draw a simple figure and that will explain things so in much better way. So here it is device 1, device 2, device 3, right? And here is our control plane and this is our data plane. Control plane, data plane, control plane, data plane. And it is our controller who is sitting here and controlling everything. And then it tells, okay, devices, you don't have to worry about the control part anymore. I'll be taking care of it. This is technically, this thing is called as the southbound interface. This is called as SBI, southbound interface. Going more into its detail, this SBI, it is something which is sitting between the controller and the device. So technically what SBI is? SBI is nothing but it is a protocol. It is not a physical interface. It's a protocol, right? So it is the protocol which is running so that controller can actually talk to this device. And when this is happening, so we require some interface. We require some interface, and that is what is called as the application program interface, or API. So whenever we use this word API is nothing but this is one program and this is second program, and when this one program wants to talk to second program, you require API, right? So over here, if you see it, it is more or less the similar thing. If I say this is a controller, obviously controller would be running some program, right? This is device, so he is also running some program. So they both are programs, and these two programs, they should talk with each other. So this is running one program, this is running one program, and then there is API in between, so which will be helping to communicate between both of them. And what SBI is, southbound interface, it is a protocol, right? It is a protocol. In this protocol, various types of APIs can run. So that's the reason, let's say if there is function 1, function 2, function 3, so there might be a separate API for function 1, separate API for function 2, separate API for function 3. When we talk about SBI, southbound interface, it is a general term which is combination. So that's the reason that there would be some controllers who will be controlling say function 1 and 2. So in that case only this much is running. If there is some fantastic controller, so he is running all three of them. So that's the reason we said that it keeps on varying for all these operations. That is how much it can really control. Now these controllers, Cisco came up with so many different controllers, right? Say for example, and we'll be studying all of them today. Say one, which is, this was not actually from Cisco, OpenFlow is open standard. Then Cisco came up with OpFlex. This is from Cisco. And yes, for exam, you have to remember this. That's why I'm writing everything in the form of keywords, so it becomes easy. Third, this is again from Cisco. This is what is called as the APIC EM. So don't worry, all of those things we'll be discussing at length. Right? Now comes the second component of it. If there is southbound, so there has to be a northbound, right? If there is southbound interface, so then there has to be a northbound interface. So what about, how about these directions, that this is south and this is north? It's very interesting. Whenever we draw a map, we draw something like this, and then we write N. This is north. So when we draw any of the design of the controller, we draw it's something like this. That this is our controller, and here is the device. Here is another device, right, which we are controlling. So we'll call it device 1, device 2. So this is SBI, and this controller is to be fed with the data so that it can actually process it and send it to these devices. So when it is talking with others, so that's why it is called as the NBI, because it is placed over there. This is north, this is south. So that's why northbound interface and southbound interface. Now, function of NBI is very classical. What really happens that this controller won't be getting a dream that all the devices which I am supposed to control, so then those devices, they are like these specific switches. Then it has to know that which ports are they talking about, what are the, say, interfaces, what's their state, whether they are up or down, what are their IP address, right? VLANs. So much of information is to be fed. So all this information controller takes and then processes it and sends it to all those devices. So this is the reason that this piece of information is fed by NBI, and the result which comes out is via SPI, right? So this is input, this is the controller, and that's the output. Because this is in the north direction, that's why it is called as the northbound interface. This is in the south direction, that's why it is called as southbound interface. That's it. Okay. Now moving further, step by step, I'll keep on adding those new concepts. Now this is NBI. Now this NBI can speak, let's say, English. But then there are various devices. They say that yes, we want to give our data to you, but we don't know your language. They know their separate languages. Let's say this device says I speak in German language. This says I speak in French. This will say I speak in Hindi. Sorry. So for this function, we need to, once again, that API will come into picture, because it is program to program. API is nothing but program to program. This is also running a program, but this time in this program it is giving information, and over here what was happening, this program was like initiated by controller and was trying to control all those devices, right? So here the bottom line is that everywhere it is this API which is coming. So API is to be prepared, and for that, that's what is called as the Java based API. So obviously that language would be used which can be understandable by every device, right? So it's like those vendors, they will make these APIs so that that device can communicate to controller, or even other companies say they will make this API. Even you can make the API so that this device talks with that controller. Now everyone will be putting various functions for the control, and that's the reason that there are several controllers which will be functioning for this entire operation, right? Okay, so here it is in nutshell. If we summarize it, this is our controller, right? This is our controller, and this controller was fed by NBI, and via SPI it is controlling all those devices. Quite easy. And in this process we are using, say, Java API. Now complete focus. It is, we said that API, right? We said that this API is for program to program. But what if this work becomes heavy, if this work becomes heavy and we distribute this work across several devices, right? This is like one way we were telling that yes, there is a central controller who is handling everything, and now suddenly we are telling that this API is spread across various device, various physical device. Yes sir, it is on various physical devices. The whole idea is the ease of management. So the way we made that API will be talking to that device to whom we really want to control, whether it is a switch or router, right? But then this function of API, it can be implemented on various hosts, right? They will be handled by various computers. And when you are doing this, so then it is very much necessary. So when we were talking about this API 1, we were telling that it was running on just one system to make the concept easy. But now things are not like that. Now the things are that we want to distribute this heavy work across several hosts. And when you are doing it, so it means you need some communication between them, and that's the reason that there would be requirement of network, means they should be interconnected, and at the same time this API, this thing should be HTML based so that they can talk effectively. And when we have got this situation, this is what is called as the REST API. It is called as the REST API, this entire concept. The concept of distributing APIs onto various hosts so that they communicate with each other via HTML. And that is what is called as the REST API. This REST, it's not so that it is taking Aram, but this REST is representational state transfer. So everyone is transferring their state, and that's what is called as the REST API. So over here in REST API, the concept is distribution of work. So this is distribution of work. Now let's take it one step ahead and what this REST API would do. This REST API will be transferring all those variables and values, and then they can be used for programming. Now I'll give you one example, right? Though we are deviating from the topic slightly, but not a problem. You know those keyboards for music, right? For music, all those keyboards, right? People play those keyboards, and there is something what is called as the MIDI. So this is the musical interface, digital musical interface via which you can connect it to your computer. So there would be MIDI in, MIDI out. So there can be even the MIDI connectors, or now it is available via USB. Whether it is say MIDI connectors or USB, the whole idea is very simple, and that is that it would be sending it the variables and values. It means if there is a tune which you are playing, it is not actually sending the music, but it is sending all these things into the digitized format, and then your computer is processing it. So it's like on various tracks, if you are feeding, so over here from the speakers, so it is the same sound which is coming. But over here, let's say your drums, they are on one channel, then your say clarinet is on another channel, your say accordion is on separate channel, and then going into the various Presonus Studio or various softwares, you can really edit these things. So this is quite similar. Over here, say this REST APIs, when they are communicating, they are just sending all those variables and values. They are not transferring the entire, say, routing table, prepared routing table, but it is sending that piece of information which can be used later for programming. Now, this is a very big thing. Why it's a big thing? Because if you can really program, so then you can do automation. So that thing straight away was like a big idea, that if we can send all this communication, right, all these variables. Why I compared it with the music industry? Because you'll be surprised to know that this MIDI concept is since 1983. Since 1983, this is in action, and still today we are using it. That's okay. Now there is a MIDI version 2, but still concept remains the same. So same way for the network programmability, like all those values, all those functions, because they are values and functions, that means they can be programmed. And if they can be programmed, if we use a common format, right? See, since 1983, MIDI is using a common format. So that's why even today, the ports have changed. The ports have become like, say, USB. The ports have become like Thunderbolt ports, Thunderbolt 1, 2, 3, but basic concept remains the same. So same way over here, if there is a common format for these variables and functions, so then it is very much possible to do network programmability. Network programming becomes easy. And as soon as this thing started, people jumped over it. And there came some very fine concepts. The first concept which came, it was like JSON, right? JSON is that for network programmability, it is JavaScript object notification. Object notification. Then XML, right? Extensible markup language. So that is XML. Now because these things, they are in common format, so it becomes much easier to go for the network programmability. So we were discussing controller, right? And just from the software portion, we said that there is a northbound interface, there is a southbound interface, and we were using those APIs. From that, we said that the load of API is very high. So then let's divide it into various hosts. And then we came up with the concept of REST API, right? And then we said that anyone can develop these things, so it has to be into some common format, and there came the concept of JSON and XML. And how many functions you are using? Well, you can use more functions, you can use less functions. That's entirely up to you, because this is programming, right? So this is programming, and this is a software. Now this gives a very good business idea. The business idea is that even you can program, and once you program, you create a controller. So your controller is now controlling even Cisco devices, because Cisco is understanding the language of this Java, and that's how you create a controller which is handling those Cisco devices in a very good way. And yes, then you can market and then you can sell that thing. And that's the reason so many companies came up and they started this business. So many third party solutions, they are what is called as the third party solutions. But Cisco was having something different in mind. Now we are coming up with Cisco solutions. Now way back, for this we have to go back slightly in history. So software defined networks and network programming, the concept was very good, but it was not started by Cisco. It started by one foundation called as the ONF, Open Network Foundation, right? Open Network Foundation. What they say, that if we work effectively, so then it is possible to control any of the devices. And then they came up with what's called as the OpenSDN, Open Software Defined Network. And this was for everyone. This was for everyone. And name of their controller. Now you know that when we say name of their controller, that means it is a piece of software, right? So it was, say, ONF model, right? The ONF model of software defined networks, and name of their controller was OpenFlow. Name of the controller was OpenFlow. So it's like OpenFlow will be taking care of all the features. So this OpenFlow will do what? It will work on the switch abstraction. It will work on switch abstraction. If you remember, I said that this is your A6. A6 would be talking to TCAM, right? It would be talking to TCAM, and this is like for those rapid table exchange, rapid search. And this concept, which is called as the switch abstraction, so OpenFlow jumped into this. It said that yes, I'll be helping for this switch abstraction, and that way I'll be more efficient than layer 2 or layer 3 switch. Any brand, no problem, I'll take care of it. So this was the OpenFlow concept. So obviously we know that controller has got a huge function. This OpenFlow, which was a controller, it has got a big role. Two such other controllers were there. Right? Two such other controllers, they are worth mentioning. And this all we are talking about 2010. Right? We are talking about almost 2010. The first one was Open Daylight Controller. This was Open Daylight Controller. Now this Open Daylight Controller, different vendors they were working on it. So many vendors. And all these vendors, it was the year 2010 when this project was in full swing, right? Most successful, means all of them they were successful by this 2010. So this is like different vendors joint operation, and all of them they were working on 2020. But now it is managed by Linux. This project is still in action, but now it is managed by Linux. So what it is really say doing? Now we'll be adding some more points into this. So we said that this is our controller, right? In that controller, there is a core function which is running, and we have got northbound interface, we have got southbound interface. I'm adding some extra things to this, and that is the application. So there is some application running, right? This application should talk to our this controller. So that's why we are writing REST API, because we are distributing this controller on several hosts. So we have got the REST API. For this REST API, right, what language should we use? So we say that we'll be using Java, so that it can talk to everyone. So we have got Java API. Well, fine. And then this SBI, southbound interface, it would be talking to whom? It would be talking to devices. Very true. It would be talking to devices. Which devices? Cisco devices only? No, any device, right? Because it is OpenFlow. So that's why this thing is called as the OpenFlow, because it was for everyone. But then it is not ending at that point. New things came up. OpenFlow was there, then came PCEP, then came BGP LS, then came OVS DB. Now all these, they are nothing but they are various controllers. So if we say this PCEP, right, it is just a different concept. It is like path computation element protocol. So if we say BGP, BGP is this border gateway protocol. LS stands for link state, right? It is border gateway protocol link state. Then this OVS DB, this is open, and now comes the vSwitch, the virtual switch, vSwitch database management protocol. So suddenly this virtualization has started entering. Yes, it was this time when they said that yes, these things should be able to control even virtual switches. So how are the things going? Previously we were talking about those physical devices, and we prepared a controller, right? This controller is controlling the devices. Fine. and then we said that we'll require all those, say, apps to control. Agreed. Then there would be, say, API for it. Till now this was fine. Then we said that we want to implement this API on various machines. Okay, so we said no problems, you use REST API, right? Because we really want to implement it on that. So we said that we'll be using our Java language, the Java API. So then also it is fine. But then suddenly we are telling that we have got even other technologies also. Yes, we do have. And in this technology, we have got even OVS DB. Yes, we have got that, right? It is working like this only. But what it will be doing? It will be working even on virtual switches. It will be working on virtual switches. Now this is something amazing. It means this entire practice, whatsoever we were doing for physical devices, is practically implementable even on virtual devices. Okay, Java API and REST API together. Okay. Say REST API, REST API, it comes into picture only when you are using and when you are spreading it across various hosts. Then and then this REST API will come into picture. Otherwise, if everything is running only on one machine, so it is a single API. Java would be the core language for preparation of such APIs. Right? So when we talk about this API, when we talk about this, talk about this. So this is on one system. And when we are talking about on various systems, so it is that when the REST API will come. Okay. So then came, so it was year 2010 when Cisco came up with the idea. Cisco said that I'm launching my own OSC. That was Open SDN controller. But one thing is very clear, that Cisco, whenever is working, it keeps on working for something innovative. Very soon Cisco said that no, I don't want to do this. And recently Cisco has stopped even marketing of this Cisco OACS. Right? It has stopped marketing of this. Why? Because they are now moving towards a very strategic thing. This is a strategic movement for what's called as the IBN. IBN. This is what is called as the intent based networking. Intent based networking. Now this intent based networking is way beyond this just OpenFlow. What this IBN or the intent based networking is, this is a form of network administration. But this network administration is combination of so many things. It's a very nice combination of one, AI, artificial intelligence. Then second is network orchestration. I'll explain every word because then immediately you will find that what's the depth of this intent based networking. And the third thing is machine learning. So over here, you are not telling only for the administration, but you are taking it way beyond. Now, first, a very important concept is orchestration. Whenever we talk about orchestration, is it automation? Well, there is a very big technical difference between that. Say, when we talk about automation and we talk about orchestration, now actually orchestration is nothing but it's like automatic programming the behavior of network, right? That is what is called as the, I'll write the keywords, it is automatic programming of behavior of network. But when we say is it simple automation, the core difference is this: when we talk about automation, it is for single system. It is like a musician who is playing his own instrument. But when it comes to orchestration, it means here you are handling many tasks together. So actually it is like orchestration, really like playing on orchestra. So let's make it simple. I'll do it like this is for single task. This will make things much easier. This is for single task, that is automation, and this is for multiple tasks, and then you are taking it at a higher level, implementing it into multiple devices via controller. Right? So that's how the whole game is played. Okay. So Cisco came up with the idea of ACI. They said that this is application centric infrastructure. Now, this was an amazing idea. Cisco said that there are two companies, say Cisco and Apple. They always think from the perspective of user. Now over here, Cisco said that who really cares? Users don't care that whether my this switch is working or this router is working. I am concerned with my work. My work should be going good. So this Cisco ACI, application centric interface infrastructure, what they said, Cisco deployed the teams. They said start working on it, and with the focus that users should be comfortable, users should feel good. So they said that OpenFlow is fine, right? But three teams would be working. Team 1, you'll be working on data center, because there are so many Cisco devices. Thousands and thousands of Cisco devices are there, and those devices, say if we don't do anything, it would be difficult to progress. Then second team, you will be working on campus network, which is spread across data center, which is in one room but heavily stuffed, heavy data campus, which is spread across. And third team, you will be working on WAN. So Cisco deployed his three teams for working on this, and then everyone came up with the ideas. Data center team said that yes, we have, say, Cisco ACI, application centric interface. This campus team, they said that we have also come up with a solution, and we call it SDA, software defined access. And today you are using So many of these technologies, sometimes even without knowing, because these things have become so transparent. And then they said that we come up with SD WAN, software defined WAN, right? Software defined WAN. So these were the three solutions given by three teams of Cisco. Now, right now we'll be first talking about, say, this ACI. This ACI, they said, okay, tell us what you have got. What that team said, that the old concept is what we saw, lots and lots of equipments, right? There are lots of interfaces. There are so many equipments. That is the physical equipment. Now, whenever there is a physical equipment, that means there is always a limitation. There is limit to expansion. There is limit to expansion. It's like at your place, you will say that I have got huge data. So fine, you will deploy the hard disk 1, 2, 3, 4, 5, 20, right? But it is occupying space. It is taking up your power. The moment you said that, yes, I am putting everything on cloud, and the concept changes. It is like just one high speed bandwidth, which is with you, and then that is taking care of your entire data. So same way over here, when this application centric, the first thing they said that this new concept, it would be taking care of, there would be softwares, this will be taking care of virtual machines, right? And that also in such a way that it would be like a self-service, so that you have cut down the administration. And then not only that, users should be able to add or remove any of the service, right? So that they said is as elastic service. Not only that, there should be the possibility of movement of virtual machines, and all these things, they should be happening as per the will of user. Now this was so good. Now today, if you see Amazon Web Services, right, what is that? You just go to their portal, and from that portal, you decide that what you want. You want a virtual machine? Yes, you decide the RAM, you decide the processor, you decide that what services you want, and boom, machine is ready. And you are paying for that. When you feel that, okay, now I don't need this virtual machine, fine, release it. These resources, they go back into the repository, and someone else is now using it, right? Someone else creates. How cool. So same thing happened even over here also. So this is way back when the entire thing was coming up. This ACI, they said that how should be the physical design. They said whenever we'll be going for this ACI, application centric interface, the physical design would be spine and leaf design. It is also called as the Claus network. Claus is the name of the person behind whom this name has been given. So that's what is called as the Claus network. What it tells is that this is like a spine switch, right? Spine switch. So let's name it 1, 2, 3. And then you have got the leaf switches. Leaf switch. Now these are the rules. That every spine should be talking to every leaf. Every spine should be talking to every leaf. And like this, this, and this. So this is rule number 1. Every spine switch should be talking to every leaf switch. So obviously every leaf switch should be talking to every spine switch. That is also true. But these spines should not be able to talk to each other. Similarly, those leaves should not be able to talk to each other. And very important thing, that your end devices, they should be connected to leaf, right? These are the devices, end devices. Now obviously these end devices would be like, say, servers, routers, etc. Right? Routers. But Cisco went one step ahead. Cisco said that that's okay. We can connect end device. So here is my end device, and this end device is, he said, Cisco UCS. Cisco UCS server. Is it a box? Yes, it's a box. It's a box. What can it do? It can create several virtual machines. So physical one box, but when someone will watch on the network, they will watch multiple machines. And that's the beauty of Cisco UCS. UCS is unified computing system. So it means that now we are controlling those virtual machines, right? Those virtual machines via all these systems. So let's draw this thing that over here it goes and it is over here. So we have got now Cisco UCS server. So this Cisco UCS server, which is capable of handling multiple machines. Now things, they are not ending at this point. Cisco came up with one more idea. He said that with these relief machines, if we can really control, right, with these leaf, if the end devices are to be connected, so give me one more line, and then let's change the color, right? Then it went all the way, right? Let's go and remember, I'm drawing this thing simply to let you know that it is connected with that leaf switch, leaf device. And Cisco said that let's connect one more thing, and it is called as the APIC. So what APIC is? APIC is also a software. It is running on what? It is running on some machine. Fine, right? And it said that what it will do, it will do application policy. This is the keyword. Application policy infrastructure controller. Again controller. Yeah, we started with controller, we are ending with controller. Oh yes, this is a software, right? Think of the entire picture. We started with that there is a controller, and that controller spreading across various host machines. So then we implemented REST API, right? Then we were having this northbound, and then this was the device, this is the southbound, and then we came up with the idea that let's do it at an application level. So we are doing it at an application level, right? When we are doing it at an application, so this is like, then we talked about this APIs, right? Application centric system. And now we are introducing in it the policy. Yes, we are introducing a policy in that. So let's make it something like this. To simplify it, this is where we are now. 1, 2, 3, control plane, data plane, control plane, data plane, control plane, data plane, right? And we have now got APIC over here. And it is the Cisco which is controlling all these devices, and they gave the name OpFlex. So Cisco came up with the idea that this is how I am different than others, how my controller is different than others, that my controller is taking care of the policy. Now let's take one example of this policy, that what this policy can really do. How is it so good? Right? So it will say, okay, this is your router, this is your simple router, no problems, right? This router, and there is some request from outside, and they said that all of them, they will be called as the EPG, end point group. So in our network, we have, say, a web server. There can be one or two web servers. So we'll make a group of, say, EPG web, right? So we have made a group of that. Then there can be some application servers. So the application server 1, application server 2. So we make a EPG of application. And then we have got one more. Let's say this is for database 1, this is for database 2, and we have got, say, EPG database. And then the policies would be running policy. There would be a policy which would be running between various endpoint groups. So what it help, say, as the request comes, this request would be processed as per the policy, and it is the APIC which would be controlling all of these, and it will say, okay, web server, this is something which has been demanded. Now is it will say, okay, is it okay? So this policy would be acting like a filter. It's like someone wants to see his result, right? And his whole roll number is 1, 2, 3, 4, 5. So it's say a request has come that we want to see his mark sheet of roll number 1, 2, 3, 4, 5. So you'll say, what about 1, 2, 3, 4, 4, 4, 6? So say, no. Policy is telling that only this number it is to be displayed, and I have confirmed it, right? So web server would say, okay, well, I don't know, but I'll prepare the page. Let me talk to this application. This application will say, okay, yes, I need database. It will extract the say information from database as per the policies that extract only this much, prepare the web page, and it would be sent back by the joint efforts of all of them. So the moment this policy came into picture, things became much easier. How it is easier? The example which I gave you for this Amazon Web Services, it's like no one is sitting. There is the APIC controller over here, right? Now this will simplify everything. There is a APIC controller over here, and then there is a user. There is a user, right? This user is given a graphical interface. There are scripts running. These user can run few scripts also. So in GUI, he has to click here, there, this, that, he has to select everything. But then you can make a script. So when that script runs, say you want a machine with i7, you want a machine with 64 GB RAM, and it should be with 2 TB hard drive. Now, if you want such 20 machines, you don't have to click on this i7, this, that 20 times. A script would be made. You just say run 20 times and boom, 20 machines are ready. So that's the difference, right? GUI and script. What it will do? It would go to the real hardware. The real hardware where everything is connected. Let's say this is Nexus 9000 series of switches, and then there are entire enterprise level like systems. It is the OpFlex which would be working over here, and it would say that this is the demand and this is something which we have to do. And that's how AWS, Amazon Web Services, they are functioning. Now, there would be several softwares running. There would be a software for virtualization will run, so virtual software would be there. There would be, say, cloud software would be there. Say, for example, if we store our this particular file at some location so that it is accessible to everyone, so then it has to be at some, there has to be some cloud software. So if I say that I want to store in OneDrive, I want to store it in Dropbox, so Dropbox would say okay, either you do it web based or you just download the application, and it is via that software will be communicating with that cloud, right? And then there could be some automation software. So all those things, they will be running, they are connected with your APIC controller. The whole idea is that over here, users, they are getting it seamlessly, right? Getting the services seamlessly. Then came Cisco APIC EM. Cisco said that this is complete injustice if I tell my users that you throw away all your current infrastructure and you start say buying my new stuff. Cisco said no, this is injustice, right? So when they said that, Cisco saw that Cisco's own products, that customers are having their own products in huge amount, so it would be an injustice. So they came up with the idea of Cisco APIC EM, enterprise module. Now this thing came in the year 2015. In 2015, they came up with Cisco APIC EM, enterprise module. Now, is it a new thing? Is it the same what we learned? No. In fact, it has got limited features. Cisco said that you keep all old hardware, don't throw it. I'm giving you something which can be used even for your current infrastructure. And I'm offering you, and it offered enterprise SDN. Now people were happy, but there is a limitation. He said that we can't do everything, but still will ease your troubles. So there came the controller, APIC EM. Now you are now familiar with that. This is our controller. This is with our northbound interface, and this is with our southbound interface, and obviously this thing will be connected to various devices, routers and switches. And over here, Cisco said that I'll use command line interface, I'll use telnet, I'll use SSH, I'll use SNMP. All those things which are so basic, and all our devices, even if they are old, they understand this language. This is the core operation of that controller, so that is core. And then this NBI, they said that yes, if the work is more, so REST APIs they would be working. Otherwise, Cisco said that I am giving you my own applications, because these are my babies, right? All these devices, they are my babies. So I know exactly what language they understand. So I am giving you my apps. So these are the apps from Cisco. So Cisco said that use these apps. Like, say you find it difficult to configure QoS, so use Easy QoS. It will make your life easy, right? Use this, so this becomes like plug and play. Use something like path trace, topology map. So Cisco said that I'll be using all those technologies which are already there into my device, but because it would be done by the controller, so you don't have to say be in trouble to design that. My controller will do that. So here, this new APIC EM, this APIC EM, it will use what? Not bound interface. Yes, via not bound interface, it will learn that what is the current configuration state of all devices, and then it will start configuring it. But will this configuration be centralized? Technically no. Technically no. The point is that from here, right, let's go back to this. Over here, let's say this is device 2. This is a very important concept. Device 1, this is device 2. So here, controller till this point of time was feeding all the babies together. Cisco said, well, these babies, they don't understand this language. But because we have centrally controlled everything, we have centrally processed everything, so now we'll feed every baby individually. So that's the thing. Here, the processing part, they have to do. But it will give the information what is necessary to each of the devices. So this is the reason, in simple words, there was controller was like what? Centralized control. Initially, it was designed for centralized control, right? The control plane, as we started our discussion, the control plane was centrally handled by the controller. But with the APIC EM, will say that yes, processing is done, but the control plane is distributed, right? It is distributed. Simply because of this new technology, new apps, it will make things easier. But otherwise, every device has to work by themselves. Interesting thing, in 2009, as this new exam was getting launched, right? In 2019, Cisco said that, okay, Baba, bus, APIC EM, DOM, no more. Why? He said we are coming up with something new, and that is where the Cisco DNA, that key. This Cisco DNA center, this is digital network architecture. So it is this Cisco digital network architecture which has been now launched. It is more extensible, very easy to manage, much easier to manage. It is like that more power has been given with better steering and control. The best is the ability to respond. So as per business, it is more responsive. So this is the reason that it has been changed. So if we go for say a summary. So we talked about OpenFlow. This thing will make everything so clear. Then we talked about ACI, and then we talked about APIC enterprise module. So over here, is this changing the traditional versus this newer type SDN? Yes, this is like a newer type. This is like a newer type. While over here, no. It is as such the things are going at a traditional level only. Is there centralized administration? Centralized administration? Well, definitely centralized administration there, here also, and here also, right? But is this centralized administration controlling the control plane? Right? Control plane. So they said yes, OpenFlow, so it was mostly it was doing it. Well, in ACI, it is partially. In fact, it is like depending upon your development. In case of EM, no, it won't do it. It will say, I can't control the control plane. Control plane can be handled only by that OpenFlow. I am just making things easier. So what SBI was used? Southbound interface. So over here, it was called OpenFlow. Right? These are all exam questions, I tell you. OpenFlow. They said that when Cisco stepped it, it said that my name would be OpenFlex. Concept is same. And over here, say they said that these our old devices, they won't be able to understand anything new. They will be able to understand just this. What is that? Command line interface. They'll be able to learn, understand SNMP. So that's how it went. Regarding vendors, so this was by ONF, right? So Open Network Foundation, and obviously these things they were by Cisco. And one more thing, if we add the name of the controllers, right? Name of controllers. So the name of the controller over here was Open Daylight, right? It was the name of the controller, Open Daylight. And over here, so it was easy. It was APIC, and it was over here APIC EM, right? So it's the same. So this is the advantage of when we are proceeding for this application based thing. So when we say API, so it all these things what we learned, it will make things easier from the automation point of view. In fact, it simplifies. Why? Why it simplifies? Because of those scripts. It is also very easy to do that modern data analysis. Right? You can analyze the things so effectively. So you know how your network is going. In fact, because you are using virtualization, so speed has increased. And you can add so many parameters for the comparison. So this is what was for today. Tomorrow we'll be taking one more step for this network automation. Thank you.